everything we've done in vectors in 2D, we're going to do in 3D. So we still write them. This is a vector from A to B. Or you might write like that. The vector OD is the same as little d by convention. That's a position vector. In the textbook, there, in printed matter, it's just bold. They usually use bold rather than writing a tilde under it. There's a stack of other things. I don't even remember what they all were. What was that for? What was that for, computer? Oh, it's back. I bet I didn't even write it, did I? No. Didn't even put all the notation in there. Not to worry. But if I'm writing like a column vector, because I'm now 3 dimensions, I'll have 3 parts. A point in 3D might be just got 3 dimensions to it. Otherwise the same. If I'm going to write in Cartesian form, I'm going to go 3i hat plus 4j hat. Then what am I going to do?
Okay.
Yep. Not very hard, is it? Magnitude. If this is W, I can find the length of W. How do I find the length of a 3-dimensional line segment? I will attempt to draw it. I'm not very good at drawing 3D, but I'll have a go. X, Y, Z. It's 3 across, 4 up, and then 1 this direction. And I want to find from the origin to that point. Right, that's my vector W. How do I find its length? Ben?
You just do Pythagoras twice.
Okay. So, what exactly do you mean by that?
Work it out for the I and J and then whatever that is in the
Okay, so let me show you something then. X, suppose it's X, Y, Z, right? Don't write this, I want you to look at the finished result. You're telling me I'm going to go, let's first work out this bit first. Right? And then I'm going to get this one. So I'm going to get this squared and add Z squared and then get the square root of that, right?
Mm-hmm.
But what's the square of a square root?
Cancels out.
So it's actually just this.
That's easy.
So that is just 3 squared plus 4 squared plus 1 squared.
Okay.
Work it out.
Does it have like a name, like someone else's formula? Like
It's just Pythagoras in 3D.
okay.
5.
Sorry?
It's in
3 squared is?
5. 9.
4 squared is?
16.
So that adds together to 25 plus 1 more.
Oh, 26 squared.
Root 26,
I said 5 because I.
which is 2 times 13, so yeah, we can't simplify that.
Yeah. How did I forget the 1? Oh, I didn't write it.
I can ask you for, I can ask you for a unit vector in 3 dimensions. How do I work out a unit vector? Yes, Ben? Other Ben?
Huh?
How do I work out a unit vector?
That A. What's the name called again? The one at the top. Yeah. And the one next to it.
No, that's just vector. That's just this. How do I get a unit vector?
It's
Anyone other than the other Ben? Anyone? Ryan, remember?
Don't you just put the coordinates over the magnitude?
Uh-huh. It's just the vector divided by its length. So it's 1 over root 26 of 3i plus 4j plus k. And Ryan, for the end of year, rationalise this. Root 26 on 26. For me, I don't care.
Okay. Are they like very strict on it?
I don't think they care either, but
Just to be sure?
yes, some people in the past care.
Okay, it just depends on the markup.
From my reading, I think it won't matter, but it's,
Yeah.
yeah. Okay, polar form is harder, but I'm wondering whether to give you some practice with that first. Do you want to practice that first, or do you want to try doing polar form as well?
Polar form.
Might as well do polar form.
Okay, it's a little bit harder. It's a little bit trickier. Have a look at this diagram again. If I was in two dimensions, and I had to get to some point. Whoops, that was funny. I'll just move my point. Doesn't matter. How do I describe that vector in polar form in two dimensions? There has to be someone else in this room other than Ben who knows the answer. Julia, remember. Other Ben, remember. Go on, Ben.
With an angle and a magnitude.
Correct. I get the magnitude and this angle. Now look at the three-dimensional case. How am I going to do the same kind of thing in 3 dimensions? Let them think first, Ben. How can I describe this with a magnitude and angle in 3 dimensions? Anybody else want to have a go, or let Ben answer? Can I have a go?
With multiple angles.
Correct. Which 2 angles am I going to use?
Pitch and yaw.
No. Good try, but no. So, what we're going to do is first work out this, x to y first. I've drawn my diagram a funny way. I can't show you there. I'm going to draw my diagram slightly differently, and you'll see why in a second. I actually want to go X, Y, Z. Now you do have to be careful. There are 2 different ways to do this. We are always right-handed. All of you do physics? Oh, but only Ryan's done the right-hand rule.
It's not that hard though.
Okay. Yes.
Yeah.
Right? So X is your first one, Y is your second one, and the palm is the third one. Or yeah, you can do that, right? 1, 2, 3. So that whichever way you have X and Y going tells you which direction is positive Z. X and Y this way, positive Z. These are basically the same. But if I go X, Y, Z, it's actually backwards. It would have to be negative Z. Just a convention. So what I want to do is, I want to get to, X is 3 and Y is 4, okay? And then Z is 1. Okay. So what I'm going to do is I'm first going to find this angle. And then I'm going to attempt to draw this. And then I'm going to go from there up to this point and measure this vertical angle. It's hard to draw.
Makes sense.
These 2 angles have different names. This one is called the azimuth, And this one is called the altitude. So the first angle tells me how far away am I from X to get to Y. And the second one tells me how far I am from there upwards to Z. This angle could be anywhere around the whole plane, XY plane. The altitude is always going to be up to 90 or down to negative 90. But that's what we have to try and work out. Let me find you. Do I go straight to the formulas or do I show you how they got there? And they're using theta and phi correct. So we're going to go theta, and then we need another angle symbol. So we're going to go phi. It's like theta, but the line is vertical instead of horizontal. In English, this is a TH, and this is a PH. Yeah, Greek. Right? I don't know how close the
It's a bit different in Coptic, but
yeah.
I think we call it theta. That one is the same, and then the other one is a little bit different.
Okay.
But you can.
There are 3 or 4 ways to write this even in Greek. So,
Yeah.
So how do I work out this angle here? And how do I work out this angle here? Oh, what am I going to do? Yes, Ben?
Just treat it like a 2D vector, because you're only working on X and Y and then you're working on the horizontal and Z.
Okay, so far what do I have? I have this coordinate here is 3, 4, 0, and this one here is 3, 4, 1, which means I can actually draw in this, that's 1. Where do I start? How other people try to work this out then?
Sorry, what are we working out?
Well, what's the magnitude I already know?
26.
I'm going to write this in polar form. It's going to be magnitude, angle, angle.
Yeah.
Azimuth, altitude. How do I work out these 2 angles? Let me try. Yeah?
Split it because you know the length of each one.
What do I know?
You know the length of each
Uh-huh.
one, so you can split it. I think maybe.
How big's this?
3 or is it 4?
Careful, 4. How long is this line here? 3. Right?
Yeah.
So can I work out this angle?
Oh yeah. Yeah.
Calculator.
That's okay.
Try and note this one yet? I say it all the time. You've heard me saying it for a year.
Is it one of the special triangles?
It's a Pythagorean triad.
Yeah,
If that's 3 and that's 4, how long is this?
oh,
It's 5, right?
yeah.
So what's the angle? Anybody?
Do you just know that? Like,
Yes. How many years have I been doing this, Ryan?
I don't know.
I learned that when I was your age. A long, long time ago. Okay. How long is the green bit? Well, that's 3 squared plus 4 squared, right? Which means it's root 25 or 5. So if that green length, where did my green pen go now? Down there. If that green length in here is 5,
So,
And height.
yes,
can't you just use the opposite angle because you know it's 1 and the hypotenuse because that's the magnitude?
you can. So you can do either way, correct. This one is root 26.
Because when you like use the numbers you know, because then you...
Yes, except this is a 3 for 5. I was tempted to use 5. Either, all right? You have three sides of this triangle. That one is 1, and you want an angle. So you have a choice. It is inverse tan of 1 on 5, or inverse sine, to use the numbers in the question, has been suggesting, of 1 over root 26. Try both ways and see you get the same angle. Have a go. And I've no idea what this one is. Except that it's small. Where's your calculator then?
In my laptop bag.
Well, at least you've got it here. Where's yours, Julia?
It's over there. It's just a bit of a journey.
You're excused, you need crutches.
I could use my crutch to fish it.
It's okay.
11.3.
Okay, now I want it.
Degrees?
Yeah.
I believe that. Someone else want to confirm that number?
That's what I got.
Okay. 11 degrees, close enough. So that means this is root 26
Average.
azimuth altitude. What about going back the other way? Can you go back suppose I give you 10, 135 degrees, 30 degrees. Let's try going back to Cartesian form. I'm going to attempt to sketch it. X, Y, Z. 135 means it's around here. I should do that in green, so we're all looking at the same things as we were last time. 135 degrees. That is 135 degrees. Whoops. And then up 30 degrees from the plane to the Z. Vertically up. So this is 30 degrees up from the plane. Now. No, this is really hard to draw. And then vertically. That's really hard to draw. It's hard to draw. Okay, I know the length is 10. And I want to try to work out the x, y and z coordinates. How do I get there? I don't think, Ben. I'm pleased that you're actually giving people time to think. That's good. It's hard to go directly to x and y. But if I know this is 10 and that's 30 degrees, I should be able to calculate this, right? That height. Because tan 30 degrees, not tan, I've got the hypotenuse. Sine 30 degrees is opposite, that's the z I want, right? Z over 10. So my z coordinate is 10 times sine 30 degrees. What's sine 30 without your calculator? Good. Okay, now I know this is 5. How am I going to work out the other bits? Two of you know. Ben's still writing, Julie's thinking.
Isn't no, no.
Yeah, how am I going to get there? Have a go. You'll learn more by having a go even if you're wrong.
Okay, I'm probably wrong, but isn't it just Pythagoras with 10 and 5?
Yes, you can work out this.
Yeah.
Once I know this, I've got this and some angles, correct, I can solve. So I need to know this green length. Let's call it something. V. Alright? V squared is 10 squared minus 5 squared. There's another way to get there. I can use trig as well. How do I do it using trig, Ben?
It's cosine 30
Uh-huh.
minus 10.
Or inverse cos of, can I do it that way? No, that's one way, or I can go cos 30 degrees is V on 10. Either way, you should get the same answer. Have a go. I know you've done it, Ben, give them a chance. But I want an exact answer. Have you got an exact answer or a decimal answer?
Decimal.
I want an exact value, please. You know what cos 30 is. What's cos
Square
30?
root 3 on 2.
Correct. You got an exact answer?
Yeah.
Good. You're in the habit already, they're not yet.
Yeah.
Always give exact if you can. 100 take 25 root 75, which is 5 root 3. Is that right?
Mm-hmm.
And this one, of course, that means V must be 5 root 3, correct. Both ways work. Both ways perfectly valid. Now I have this green length, I want to find the X and the Y. If it helps you, you can redraw it with just X and Y, and I've got, it's actually on the negative side, it's over here. That's 135 degrees, and this is 5 root 3. Getting confused by the 3 drawing conversions?
Yeah.
That's usually the biggest problem here, actually visualising what's going on.
I've got the first one pretty well. Like, I
Okay.
understand that one, but I don't know about the...
If you can get to this, and then you go, now ignore the vertical and just look at the green on the XY plane. You can do it from here if you're careful. What do I know? X is negative. X has to be, this is 45 degrees. So I'll write it slightly differently. What do I know? Oh, they get the same thing, right? So cos 45 degrees is X over, well, we could just put 135 in. Would that confuse you less? X over 5 root 3, and sine 135 degrees is Y over 5 root 3. These are both 45 basically, so that's 1 on root 2. Do you know your exact values for trig? You need to. So that is 1 on root 2, so we're going to have Y is 5 root 3 over root 2, and X is negative 5 root 3 over root 2. That's pretty disgusting. Root 3 on root 2, but it's the way it is.
If we get one like that, do we have to rationalise it?
They did. I'm happy with this as long as the surds are in simplest form.
Okay.
Some people say you need to rationalise, so you multiply top and bottom by root 2. And then you're going to get, if you want to, negative 5 root 6 on 2 and 5 root 6 on 2. So then you say, well, this vector is this I hat, this j hat, that k hat.